Hey, Top Airlines Math and History, and we are going to learn about calculating the angles on a clock. Or should I say, it's time to learn about angles on a clock. So what we're going to basically be doing is we're going to be using degrees, minutes, and seconds to find out how long it takes for the clock to get that much degrees. Because if you notice on a clock, an analog clock, you see an hour hand, a minute hand, and possibly a second hand. The thing is, those hands that are constantly going around 24/7 actually make up angles of themselves. Here's an example. We have one line and we have two lines. Since this is an hour hand and this is a minute hand, or it could be one or the other, they make an angle. So, when we saw the movements of a clock, we saw that it does make an angle. So, to understand and calculate the number of degrees and the time it takes to do so, there are some things that we kind of have to know about. The thing is, if 12 hours is represented on a clock because there are numbers 1 through 12, and a clock has to go around itself 2 times per day, that's why we have AM and PM. If a 12-hour clock is equal to 360 degrees, because 360 is one rotation, then 1 degree is equal to 60 minutes, because 60 minutes is equal to an hour, which is equal to 360, that has 12 hours. And 1 minute equals 60 seconds. So, if 12 hours equals 360, 1 degree is 60 minutes because that is 1 hour. And 1 minute equals 60 seconds. So, that is basically what we have to know about. We have to know about the number of degrees. The minutes have passed, and the seconds have passed. The thing is about degrees, it cannot exceed 360 degrees in this video. So, the kind of answers that we're going to look at is going to come in this format right here. So you'll see degrees as a degrees symbol. Minutes, they'll have 1 strike right behind the number, and it'll always be the middle number. And seconds will have 2 strikes, and will be the last one. Here's an example when we are talking about degrees, minutes, and seconds. So, we have, if a clock has hands that make an 84-degree angle, and it's 30 minutes, what we're going to have to do with this is we don't want minutes right now. What we're going to try and do is turn it into a fraction. So, if we have 60 minutes in a single hour, and we have 30 minutes on the top for this problem, we can simplify that to a fraction of 1/2. So, when a clock has hands made up of 84 degrees, it will have 84 degrees and 1/2. Or 84.5 if you're looking for a decimal. That's one way. Let's look at another example. So imagine this time. So if we have a clock that makes up an angle that's 10 degrees with its hands, and it has 20 now if it has 15 minutes, what we want to do is we want to leave the number of degrees. What we got to actually deal with is the measurement of the time. We have to turn it into a fraction. So 15 minutes and an entire hour is 60 minutes. We can simplify that to 1 over 4. So 10 degrees, 1 over 4. And some teachers want it as 10.25 degrees. So these two examples are examples when you want to have the measurement of a time turned into a fraction. But sometimes your math teacher might want you to do it the opposite. If we had a time, if we had degrees and a fraction, and your teacher wanted to put it in time, we sort of have to do things a little bit backwards. Well, yeah, it is about backwards and doing it in reverse. So imagine we have 60 degrees, a clock that makes 60 degrees, and it has 3 over 4 as a fraction. What is the time? So we leave the degrees right here, and we have to handle the fraction and turn it into minutes. If we look at 3/4 of a clock and we draw a diagram, this is basically 3/4 right here. So we can say that 60 degrees and 45 minutes. So that is a really good warm-up because in geometry, you'll have to know about these angles and you'll have to know about these minutes and seconds when you're solving these kind of problems. So this one was changing a fraction back to time. Now here is the problem that we're going to be challenging you guys and gals about degrees, minutes, and seconds.